Across the global satellite network, new nodes are illuminating for a specific purpose: hosting autonomous agents. The artificial intelligence industry is pivoting from web-based conversational windows to planetary-scale infrastructure. Capital expenditures for physical compute hardware have crossed the trillion-dollar threshold. Software interfaces are being rewritten for machine readers, and the integration of these systems is triggering measurable psychological blowback in the workforce. Physical energy grids and human cognitive endurance now dictate the deployment speed of artificial intelligence, replacing software code as the primary constraint. To observe this shift in physical scale, look to Austin, Texas. Here, traditional semiconductor manufacturing is being bypassed by a project designated TerraFab, an installation designed to integrate the entire chip production lifecycle under one roof. Driven by Elon Musk through a merger of Tesla, SpaceX, and xAI, TerraFab aims to produce 1 terawatt of compute capacity annually. Simultaneously, SoftBank has committed $500 billion to build a 10-gigawatt natural gas and nuclear-powered data center in Ohio. This chart captures the jump in power consumption. A standard legacy data center operates at 100 megawatts. SoftBank's Ohio facility requires 10 gigawatts. TerraFab's goal is 1 terawatt, 50 times greater than current global chip production capacity. Generating that much power on Earth creates a thermal bottleneck. To bypass this, 80% of TerraFab's yield is radiation-hardened chips designed for orbital deployment. By placing servers in the vacuum of space, operators achieve zero-cost cryogenic cooling and capture unmitigated solar energy 24 hours a day. Rather than scaling raw power, the Chinese domestic market is targeting efficiency through precision architecture. Huawei's Atlas 350 processor relies on FP4. FP4, or 4-bit floating point, is a low-precision computing format that reduces memory usage by processing numbers with fewer digits. This allows the Atlas 350 to achieve nearly 3 times the operational speed of competing hardware while reducing data throughput requirements by 60%. Artificial intelligence infrastructure is now a national-level geopolitical asset, directly bound to a country's power grid and heavy industrial output. Above the hardware layer, the software ecosystem is transitioning from user-facing applications to autonomous agents. Tencent has integrated the OpenClaw agent framework directly into WeChat, allowing a localized digital worker to execute system commands on a user's PC. Concurrently, OpenAI is consolidating its chat, code generation, and web navigation tools into a single desktop operating system designed to execute workflows without human intervention. This transition changes the target audience for new software. Y Combinator reports developers see adoption simply because their API documentation is structured for machine comprehension. An API, or Application Programming Interface, is a set of rules that allows different software applications to communicate directly. Software is being optimized for these machine readers rather than human graphical interfaces. Applications that merely repackage text generation are failing technical scrutiny. The programming tool Cursor achieved a $50 billion valuation based on claims of proprietary reinforcement learning. However, network logs revealed its flagship model was routing requests to Kimi K2.5, an open-source model developed by a Chinese startup. This indicates that many high-valuation AI applications lack a defensible technical foundation. At the foundational level, Meta's chief AI scientist, LeCun, argues that scaling up text-based large language models is a dead end. Large language models, or LLMs, are AI systems trained on massive text datasets to predict the next word in a sequence. LeCun asserts that models trained strictly on internet text lack basic physical intuition and cannot achieve autonomy without observing the three-dimensional world. System A observes the environment. System B executes actions. The core is System M, a meta-control unit dictating when to observe or act, removing human engineers. Future systems use mathematical formal verification to guarantee safe execution. Integrating this level of automation is causing acute psychological friction. A global study by Anthropic involving over 80,000 users documented the rise of an illusory productivity treadmill. As artificial intelligence accelerates output, corporate targets rise proportionally, trapping workers in a cycle of increased effort to maintain their employment status. The data reveals specific psychological casualties. 16.3% of heavy users report a degradation in their independent thinking and logical organization skills. Furthermore, users who rely on the machine for emotional support exhibit a 3 times higher probability of forming psychological dependencies compared to the baseline population. This friction extends to elite developers, reporting a condition termed token anxiety, or AI psychosis. By offloading all manual coding to concurrent autonomous agents, these engineers experience distress whenever their API token limits are not maxed out. An API token is a basic unit of data measurement that dictates how much information an AI processes at once. To these engineers, any idle machine time is viewed as a personal failure. The workforce is undergoing rapid cognitive offloading. Managing the human element as the slowest bottleneck in an automated loop has become the primary operational challenge, superseding the acquisition of computational power. Plan accordingly.